Friday, we talked about the rejection regions and how you get the critical values of the T. This slide is, again, just more of a review slide to start on how we get a standardized test statistic for T. This looks just like our Z-score formula, if you remember that, except instead of having a population standard deviation or a little lowercase sigma at the bottom, we instead have an S for standard deviation because now it's a sample. So we use these anytime we have a sample standard deviation. And of course, in order to get any critical values, we're going to need to know those degrees of freedom again. So the next slide on your paper, you're going to notice these are really similar steps to what we were doing with the Z-score statistic before. So we want to verify at the beginning that either we know or do not know that population standard deviation. We know the population standard deviation, we're using Z's. If we don't know it, we're using T's. We also want to make sure that one of those two conditions is met, either normally distributed or sample size bigger than 30. We're going to write hypotheses and label the claim. Level of significance is going to be given to us. Degrees of freedom and the critical value on our T table then are going to give us the critical value of T, the critical values of T that make it either that left tail, right tail, or two tail test, and we're going to be able to sketch those rejection regions. Then we're going to calculate our test statistic T and determine if it is or is not in a rejection region. If it's in a rejection region, we reject, but no, if we don't. If it's not there, we don't reject, and then we summarize from there based on what the claim is and what our decision was. So we're just going to do two of these because they're, again, really similar to the T test or Z test that we did before. Okay. So a used car dealer says that the mean price of used cars sold in the last 12 months is at least $21,000. You suspect this claim is incorrect, and you find that a random sample of 14 used cars sold in the last 12 months has a mean price of $19,189 with a standard deviation of 2,950. Is there enough evidence to reject the dealer's claim at a level of significance of 0.05? And we're going to assume the population is normally distributed. So that last statement, assume it's normally distributed, we meet our conditions. We also want to check our standard deviation as one of our first steps. Standard deviation here came from the random sample. So because it came from the random sample, it's an S instead of a sigma. And that tells us also that we're going to be using the T charts to get our rejection regions. Okay, I'm going to start with those hypotheses like we've practiced before. Both in this section and the last section, we're always hypothesizing about a mean still. So here it's the car dealer says that the mean price of used cars sold in the last 12 months is at least $21,000. Is that going to be a null or alternative hypothesis? What do we think? At least. Well, what does at least mean with our inequality symbols? Less than, greater than, equal to? At least means greater than or equal to. And because it's equal to, we use it as what hypothesis? The null. Okay, so my mean is greater than or equal to at least 21,000, and that's my claim. Which means the alternative is just the complement of that, less than 21,000. Okay, other information we can pull from the top there. We have a sample mean, an X bar of 14 cars. The sample mean was 19,189, and because it was 14 cars, my N, my sample size is 14. Can you tell me if this is a left tail, right tail, or two tail test? Left tail, right tail, or two tail test? What do you think? Yep, so we always look at the alternative hypothesis. It's less than, so this is a left tail test. So if I want to sketch a rejection region, we know we're going to be looking at my left tail. We need to figure out what that critical value of T is. Our book uses T sub 0. I like T sub C. You can use either one for this. Okay, in order to find that, we need two more pieces of information we haven't written down. Alpha is 0.05. We know it's left tail, and if we know N, we should also then be able to very quickly get the degrees of freedom. If my N is 14, my degrees of freedom is 13. Okay, and then that's what we're going to look up. Make sure you're using your T-chart now, okay? So on the top, we're going to find one tail. We're going to go over to 0.05, which is our second column. And then we're going to go down to 13 degrees of freedom, 1.771. Now you need to remember with this, you may have to, from the T-chart, add negatives on, or potentially a plus or minus, because it's left tail, we put a negative there. If it's right tail, it's positive, and if it's two tail, one of each. And if you don't remember that, there's little pictures on the side of your chart that are going to help you remember that. Okay, if it's left, it's negative, right, it's positive, and both we put a plus or minus in front of it. All right, so now we're going to calculate our own T value, just like we did before with Z, and we're going to compare it to that rejection region. All right, so this formula was X bar minus mu. Again, it's always sample minus population on the top, divided by standard deviation, which is now an S, over the square root of n. And we've got all this, so let's fill it in. 19,189 minus the mean from my claim, 21,000. My standard deviation, 2950 over the square root of 14. And then again, you guys will be doing this with red calculators, so you probably want the numerator and denominator simplified first independently, and then divide last. So on top I get negative 1,811. On the bottom, I get 788.42 about. If I divide those, negative 2.297. And we want to round to 3 decimal places here because that's what our T chart uses. When we used Z, we rounded to 2 decimal places because that's what our Z chart uses. Okay, is that number in our shaded region? Yes or no? Yes. Okay, so if it's in the shaded region, what is our decision? Reject or not reject? We are going to reject. And remember, you are always rejecting the null hypothesis. So you want to get in the habit of writing that down. And then we want to summarize that decision. So do we say there is or is not enough evidence if we reject? There is or is not enough evidence? Is, if we reject. Remember, in statistics, rejecting is good. It means you have enough evidence to make a decision. 2, and then we're either going to say reject or support the used car dealer's claim. If we want to relate it back to the context of the problem. Are we going to say reject or support here? Reject, good, because the claim is the null hypothesis. Okay, so like I said, really similar to what we did with these before. Nothing super crazy today. Any questions on this problem? Yeah.
So what is the alpha value?
When you look up the value in your T chart, you need alpha for that. Okay. Anything else? Okay. All right. So let's just make this our last one for today. And I'll post the third one online if you guys want to check answers to it, but we'll let you guys try this one and then we'll put answers up and that'll be it. The third one on your paper, I'll post the answers to if you want to try it on your own. I think that's a right tail test, if I'm remembering correctly. And then that's it for 7-3. So you guys have half hour work on Math Excel. So remember, both of your 7-3 Math Excels are due tomorrow night. And we got one more section tomorrow. We're going to wrap it up.
Yes. I left my house. I was